Throughout this chapter, we've been discussing the idea of slope, and we've been studying the slopes of linear equations. Now we're going to take that idea of slope into our next section. We're going to talk about parallel and perpendicular lines, and those are just lines that have special relationships to each other based on their slopes. So the first type of relationship we're going to talk about are with parallel lines. Now parallel lines are lines that are on the same plane, they're on the same coordinate grid, that do not intersect. All right, so here's our example. Let's use the example. Our first equation will be y equals 2x plus 1, and our second equation will be 2x minus 3. So let's go ahead and graph these two equations, and we'll see how they look, and we'll talk a little bit about their slopes. So, to graph our equations, we'll notice first that both equations are already in slope-intercept form. So the slope of our first equation is 2, and our y-intercept of our first equation is positive 1. So let's go ahead and graph these. So starting from the origin point, let's find our y-intercept first. It's positive 1, so that's on the y-axis here at positive 1. And then let's use our slope. Now the slope of 2 is the same as 2 over 1. So our rise is 2, our run is 1. So starting from that y-intercept point that we found, we're going to rise 2 and run 1 to the right. So we have 2 points. All you need to graph a line is 2 points on that line. So let's go ahead and use our straight edge, connect our lines, or our points, with a line. Okay, so there's our first equation on the graph. Now our second equation, let's take a look. Our slope is also 2, and in a fraction that's 2 over 1. Our y-intercept, in this case, is negative 3. All right, so let's go ahead and graph our equation using the y-intercept and the slope. So we're going to start at the origin point, go down to our y-intercept, which is negative 3, where the line will cross the y-axis at negative 3. We're going to use our slope. Our rise is 2, our run is 1, rise over run, so up 2 and to the right 1. All right, notice that these lines have no points in common. They will never cross, they will never intersect. And if you'll notice about their slopes, they have the same slope, because as these lines continue infinitely in both directions, their rate of change is the same. They are rising and running at the same rate because their slope is the same. So these lines will never, in a sense, catch up to each other. They will never cross, they will never intersect. So parallel lines always have slopes that are the same. Okay, the other kind of relationship that we are going to examine are between perpendicular lines. So perpendicular lines are just lines that intersect at right angles. Okay, a right angle being a 90-degree or a perfect corner, such as the one on this paper, a perfect corner. Okay, so our example is going to be y equals 1/2 x, and our other equation we're going to compare it to, y equals negative 2x. So let's take a look at our first equation. Our slope is 1/2, 1 over 2, and our y-intercept, in this case, is 0. Let's take a look at the second equation. The slope is negative 2, which is the same as negative 2 over 1. And the y-intercept, in this case, is also 0, because remember our slope-intercept form, we have y equals mx plus b, where m is the slope and b is the y-intercept. When we don't have an added constant term over here, that's the same as adding 0, so our b, our y-intercept, is 0. Let's go ahead and graph these equations. So the first equation, y equals 1/2 x, our y-intercept is 0, so let's go ahead and start at 0. Our slope, our rise over run, is 1/2, so we're going to rise 1 and run 2. So we're going to rise 1, run 2. So here is our first line. All right, our second line, we have a y-intercept of 0, so plot that first, y-intercept first of 0. Then our slope is -2/1, so -2 is our rise, so we're actually going down, -2, and we're going to run 1, so to the right 1. So these two perpendicular lines are forming a right angle. Right here they're making the perfect right angle, 90 degrees, a perfect corner. So notice the slopes on these perpendicular lines. What is the relationship between 1/2 and -2? Well, we have one slope that is positive, the other slope is negative, so they are opposite. Now the reciprocal of 1/2 is 2/1, or 2. The reciprocal of 2 is 1/2, or 1/2. So these numbers, 1/2 and 2, are reciprocals. So the slopes, notice, are opposite and reciprocal of each other, and that will be the case with all perpendicular lines. Okay, the slopes are opposite and reciprocal. So you'll have one positive slope, one negative slope, and then they will be reciprocal of each other. Let's go ahead and take a look at some examples. And we're asked to determine whether these lines are parallel, perpendicular, or neither. So let's take a look at the first set of equations. They are already in slope-intercept form. So we can go ahead and take a look at their slopes. That will tell us if they are parallel, perpendicular, or neither. So the slope of the first line is 1/3. The slope of the second line is -3. Well, we have a positive slope and a negative slope. 1/3 is the reciprocal of 3, and 3 is the reciprocal of 1/3. So these slopes are opposite and reciprocal. So they are perpendicular. Let's go ahead and graph these. All right, so the slope on the first equation was 1/3, and our y-intercept was 2, a positive 2. And our second equation, our slope is -3, and our y-intercept looks like +4. Let's go ahead and graph our first equation. So our y-intercept is 2, so from the origin point we're going to count up 2, where the line is going to cross the y-axis at 2. We're going to use our slope. Our rise is 1, our run is 3, 1/3, so we're going up 1, running 3. Okay, let's go ahead and draw our line. Okay, our second equation, our y-intercept is 4. So we're going to start our first point on 4, the y-intercept, where the line is going to cross the y-axis at 4. And our slope is -3, which is the same as -3/1. So our rise is -3, our run is 1. Our rise is -3, we're going down 3, 1, 2, 3, Our run is 1. Let's go ahead and connect those. Okay, let's take a look. It does appear that the lines are forming a right angle, a perfect corner, 90-degree angle. So they are perpendicular. Let's take a look at the next example. Now these equations, this one's in slope-intercept form, but this one isn't. Let's go ahead and put this first equation into slope-intercept form. That way we'll be able to compare the slopes a little more easily. So if I was going to put this in slope-intercept form, I'm starting with 3y plus 6x equals 12. Let's go ahead and get the y by itself, because remember in slope-intercept form it's y equals and then the rest, so we can look at that y by itself. Okay, and remember, to get that y by itself we need to divide by -3. Whatever we do to one side we have to do to the other side, and we have to do to all of it. So -6 divided by 3 is -2x. 12 divided by 3 is 4. So here is our first equation in slope-intercept form. Here's our second equation in slope-intercept form, and let's take a look. Well, it looks like their slopes are both 2. The slope on the second one is -2, and the slope on the first one is -2 as well. They have the same slope, so they must be parallel. Let's graph them just to double check. So our first equation, our slope was -2, our y-intercept is 4. So we're going to start from the origin point. Let's go up to 4, where the y-axis is 4, where our line is going to cross the y-axis at 4. Then let's use our slope. Well, -2 is the same as -2 over 1. So our rise is -2. We're going down 2, and our run is 1, going over 1. Okay, there's our first line. Let's go ahead and graph our second line. So remember, the slope was -2, same as -2 over 1, and our y-intercept, in this case, is 8. So let's start at the origin point, go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And our slope is -2 over 1. We're going down 2 and over 1. Okay, and it appears those lines are parallel. They will never cross, they will never intersect. Okay, the last example on this page, let's take a look. So it appears they are already in slope-intercept form. This one has a slope of 2. This one has a slope of 3. Now they're both positive, so they're not opposite. And 2 is not the reciprocal of 3, and 3 is not the reciprocal of 2, so they're not reciprocal either. And 2 and 3 are not the same. Okay, so if they're not opposite and they're not reciprocal, that means they're not perpendicular. If they do not have the same slope, they're not parallel. So they're neither. Well, we can go ahead and graph just to make sure. So our y-intercept on the first equation is 4. 1, 2, 3, 4. Our slope is +2, so we're going rise 2, run 1, rise 2, run 1. Here's our first line. Our second equation, our y-intercept is 1. Starting up here at +1. Our slope is +3, or +3 over 1, so we're going rise 3, run 1. Let's go ahead and draw our line. All right. You can see that they're not parallel, obviously, because they cross here, and they do not cross at a right angle. So They're not parallel, they're not perpendicular, they are neither. All right, last page of examples. Okay, what they're asking us to do is we need to find an equation of a line passing through this given point, -1, -2, and we want it parallel to this equation. Remember, parallel lines have the same slopes. So, if we want a line that's parallel to this one, we want the same slope as this one. So this given equation is already written in slope-intercept form. So the slope of the given equation is -3. Since we want a parallel line, we want the slope of the new line to also be -3. So our new line, we want our slope to be -3. Now we also want this point. And we also want it to pass through -1, -2. Now we know a form of an equation that deals with the slope and a point on the line. It's called the point-slope form. Remember, point-slope form looks like y minus y1 equal to the slope, which we call m, times x minus x1. So we can go ahead and plug in our slope, which is -3. Remember, the x1 and y1 are a specific point. The regular y and the regular x are just the x and y in general. So we're going to keep our x. Let's use our specific x1 and our specific y1 in our equation. So minus x1 minus -1, which is the same as adding 1. And then on this side, we have our y minus y1, and our y1 is -2, so minus -2 is the same as +2. Okay, so this equation would be the one. Now, if you're not as comfortable with point-slope form, you could also use the slope-intercept form. So here's another way. Using your slope-intercept form, y equals mx plus b. Now, remember we want our slope to be -3, and we want our point to be -1, -2. So, let's use our slope, and let's use our point that we know in the pieces of the equation that we have. We can solve for the y-intercept and then find our equation. So we know, well, we have a y-coordinate, which is -2. We have our slope, which is -3. And we have an x-coordinate, which is -1. Now all we have to find is that y-intercept, our b. So let's simplify. -3 times -1 is 3. Okay, go ahead and subtract 3 on both sides to get that b by itself. -5 equals b. Oops. Equals b. So our y-intercept is -5. So to rewrite our equation in general terms of x and y, we know our slope, m, is -3, and we just found our b is -5. So we can plug those back into our y equals mx plus b to have our general equation. So we'll have y equals, our slope was -3, x, plus our y-intercept, which was -5. Okay. Now, earlier in the chapter, we talked about rearranging our point-slope equation into a slope-intercept equation. Just for good measure, let's make sure that these equations are in fact the same. So let's take our point-slope form and simplify it down to our slope-intercept form, and we'll see if we get the same thing. So we're starting with y plus 2 equals -3, x plus 1. Okay, first thing we need to do, go ahead and distribute that 3. We have y plus 2 equals -3x, -3 times +1 is -3. All right, let's go ahead and subtract 2 on both sides, so we want to get that y by itself. We get negative 3x minus 5. And look at that, we got the very same thing. So both methods work. You can use point-slope form with the desired slope and the given point with the point-slope form, or you can use your y equals mx plus b, your slope-intercept form. Use the slope and the point in for x and y, and then find the y-intercept, and then rewrite the equation in general terms of x and y. Okay, both options work. Personally, I like the point slope because it's a little bit faster, but it's up to you, whatever you are more comfortable with. All right, let's go ahead and take a look at this next example. So we need to find the equation of the line that passes through the point 1, 3 and is parallel to y equals 4. Now, y equals 4, I think that was a special type of equation. Let's make a table and then draw a graph, and we'll see if we can remember what was special about these types of equations. So, here's my table with my x's and y's. Here's my equation. Now, I don't have any x's in the equation, so if I picked 0 for x, what's y? Well, y is always equal to 4. What if I picked 1 for x? Well, y is still 4. Y is still equal to 4 according to our equation. What if I picked 100 for x? Well, according to our equation, y is equal to 4. Let's go ahead and make a little sketch. All right, so 0, 4. We're looking at this first point here, 0, 4. 0, 1, 2, 3, 4. Okay. And then how about 1, 4? 1, 1, 2, 3, 4. This looks like a horizontal line. And in fact it is. It is a horizontal line. So what's parallel to a horizontal line? If we can't tell from the equation what the slope is, well, let's look at the graph. That's a slope of 0. So we need another line with a slope of 0. We need another horizontal line. Now our point, 1, 3, this is where x is 1 and y is 3. Now remember, horizontal lines are of the form y equals some number. So we want our y to be equal to what? Well, if x is 1 and y is 3, and we want a y equals equation, well, y must always be 3. So if x is 2, y is still 3. If x is 47, y is still 3. Okay, so let's graph it. All right, our point 1, 3. 1, 1, 2, 3 is right here. And our point 2, 3, 1, 2, up 3 is right here. Let's go ahead and graph it. And look at that. They're parallel, and this goes through the point 1, 3. So the equation of our line that we're looking for is the equation y equals 3. So if our given line is horizontal and we want one that's parallel to it, we need another horizontal line. So just look at your coordinates. Think about what would make sense. You can draw a graph if you need to. Now think about if we had a vertical line. What kind of line would we need if we were looking for one that would be parallel? Here's a sketch. If I had a vertical line like this, what would be parallel to it? Well, you'd have to have just another vertical line. And remember, vertical lines are of the form x equals some number. Okay, so you would find that in a similar way. All right, let's go ahead and look at the next example dealing with perpendicular lines. So we're supposed to find the equation of a line that passes through this point, -3, -2, and is perpendicular to x plus 4y equals 12. Now, we need to examine the slope, and it's hard to tell the slope from this form of the equation. So let's put it in slope-intercept form so we can more easily see the slope. So we're starting with x plus 4y equals 12. Let's get that y by itself. All right, to get rid of that 4, we need to divide through by 4, divide everything through by 4. Well, negative 1x divided by 4 is just negative 1/4 x plus 12 divided by 4 is 3. So here's our given equation. The slope is negative 1/4. Now we want a perpendicular line, so our new line, we want our slope to be opposite and reciprocal of the line they gave us. So our new line needs to have a slope of, well, the opposite of that would be positive, and the reciprocal of 1/4 is just 4/1, or 4. We want it to go through the point -3, -2. So we have the new slope that we want, we have the point that we want. We can use point-slope form, or we could use slope-intercept form, similar to the two ways we did up here. I'm going to do the point-slope form because it's faster for me. So remember, y minus y1 equals m times x minus x1. So our m is 4. Our x1, y1, x1 is -3. So if we're subtracting x1, minus -3 is the same as plus 3. And our y1 is -2. So if we're subtracting y1, we need to subtract -2. That's the same as add 2. And there we are. There's the point-slope form. Now, if you wanted to, similar to the top here, you could also solve using the y equals mx plus b, or the slope-intercept form. So our slope was 4, and remember our point was -3, -2. So x is -3, y is -2. Let's plug them in. Plug in what you know. Now all we have to do is find that y-intercept, find the b. So -2 is equal to, well, 4 times -3 is -12. Let's simplify. Okay, -2 plus 12 is 10. So our y-intercept is 10. Now we have our y-intercept, we have our slope, so let's rewrite the equation in terms of general x and y. So we have y equals 4x plus 10. Now, like we did at the top, for good measure, we could double check to make sure that this point-slope form is the same equation, really, as the slope-intercept form. So we're starting with y plus 2 equals 4 times x plus 3. All right, distribute that 4 first. You get 4x plus 12. Let's subtract 2 on both sides. You end up with y equals 4x plus 10. And it looks like we get the very same thing as we had over here, so we know we did it correctly. All right, last example. We need to find the equation of a line that passes through the point 3, 1, and is perpendicular to x equals 5. Now, if you don't remember what type of equation an x equals a number equation is, you could make a table. Well, according to this equation, x is always 5. So when x is 5, y could be 1, or when x is 5, y could be 2, or when x is 5, y could be 1,000. According to this equation, x is always 5. So let's make a little sketch. All right, let's take a look at the point 5, 1. 1, 2, 3, 4, 5, and up 1, about here. And let's take a look at the point 5, 2. 1, 2, 3, 4, 5, up 2, about here. All right. So what is perpendicular to a vertical line? This line is vertical. Well, this is an undefined slope. You can't find the opposite and reciprocal of an undefined slope. But think about it. What's perpendicular to a vertical line? If you had something going straight up and down, how would you make a right angle? How would you make a perfect corner, a 90-degree angle? Well, use a horizontal line. Horizontal lines will always be perpendicular to vertical lines. We want it to go through the point 3, 1. So let's find that point. 1, 2, 3, up, 1. And we want it to be horizontal, going through this line, or going through this point. So what is the equation for this line? Our horizontal line that is perpendicular to the given vertical line. Well, let's maybe pick out a couple of points that we can see on this line. Well, we know for sure one of them is 3, 1. What about this one right here? It appears that they quite possibly could intersect. 1, 2, 3, 4, 5, 3. Oh, I'm sorry, 5, 1. 1, 2, 3, 4, 5, and up 1. Yes, what am I thinking? 5, 1. Okay. We could also take a look for some other points. Well, here's the y-intercept right here. That's at 0, 1. So it looks like no matter what x is, y is always equal to 1. And we know that the form of a horizontal equation is always of the form y equals a number. And in this case, we want our y to equal 1, just like in our point.